Here we have a question discussing a model rocket being shot off the roof of UMEI. Its flight path through the air is modeled by this equation, and you can see that it has height in meters and t, time in seconds, as the variables. The question we're trying to solve is, what length of time is this rocket 35 meters above the ground? The first thing we have to do to solve this is to take our equation and set it equal to 35. The left side of the equation represents the height of the rocket, and we want to know when that height is 35. So we set the height equal to 35. Now, in order to solve this problem, we move the 35 over to the left-hand side. That creates minus 5t squared plus 30t minus 25. This is because we had a 10 here and a 35 here. So 10 minus 35 is 25. We also see that it's equal to 0. Now we can factor the equation in order to solve the problem. We first can take out a common factor of minus 5. This leaves us with a simple trinomial. So all we have to do now is think of what multiplies to 5 and adds to negative 6. We come up with minus 1 and minus 5. Now, since we know that minus 1 and minus t minus 5 are the factors, and that 5 times t minus 1 times t minus 5 has to equal 0, we know that t minus 1 must equal 0, which means t is 1, or t minus 5 would equal 0, so t would be equal to 5. So that means that the rocket hit 35 at 1 second and at 5 seconds. So that is a total of 4 seconds for which the rocket is above the ground. Above 35 meters, that should say. Let's take a look at this visually. This represents the path of the rocket. It starts at 10, has a maximum after 3 seconds of 55 meters, and hits the ground just after 6 seconds. The question is asking for how long is the rocket above 35 meters. So we can draw a line here at 35 meters, and it will be above that between this point and this point. So what we did in our problem is we found this to be 1 second and this to be 5 seconds. So therefore, the rocket is above 35 meters for 4 seconds. Thanks for watching. I hope you liked it.